Hello, hi. Today we will talk about order of differential equation and degree of differential equation. So these are some vocabulary associated with differential equation. Is good to know. Very simple, very simple. So let's just think about order. So I wrote down the definition of the order. So the order is the highest derivative of the unknown function that appears on the differential equation. So the unknown function most of the time will denoted by y. And remember, we're thinking y as either y of x or y of t. If you see the variable x, then the y is going to be function of x. If you do not see any variable, you can choose any one of them. So that's the order. So the highest derivative that you see of the unknown function, that's the order. And the degree is the exponent of the highest derivative. That's the degree. So it will be clear if we look at this example. So let's look at this example here. What is the highest derivative that we see? Is y triple prime, right? I see y double prime and y triple prime. But y triple prime, or the third derivative, that's the highest derivative. So in this example, the order of this differential equation is 3 because the highest derivative is the third derivative. How about degree? So for the degree, you look at the exponent of the highest derivative. We do not look at y double prime because that is not the highest derivative. So you look at the y triple prime, and the exponent of that is 2. So the degree is 2, not 5. See, 5 is the exponent of y double prime. That we do not care because y double prime is not the highest derivative. So you look at the highest derivative and you look at the exponent. That's the degree. And that's how easy it is. Before I do a few more example, let me clarify a notation. So um, let's look at a notation here just to clarify this. Okay. So when I say, for example, y and the parenthesis 5, right? Whenever you see a parenthesis in the exponent, it's not really an exponent. So the notation here, that refers to the order of the derivative. So in this case, this means fifth derivative. So another way I can write it down, the 5, I have to put this 5 prime. Once we go beyond third derivative, we usually don't write all of this prime, right? Think about the 100th derivative. Wow. So you have to start with y. Oh, 100 of them. Oh my God. That's too much, right? And we don't want to do that, right? Instead, we just put y and in parentheses 100. Okay? Another way I can write this one is, the denotation like that. I can do the same thing here, the denotation for the 100th derivative. So this is good, this is good. But this is not so good once you have a very high order derivative, right? Compare this with if I just have y to the power 5, no parenthesis, right? That is indeed exponent. So that is actually y times y times y times y times y. So make sure you see the difference, right? If I do not have parentheses, it's just a regular exponent, right? If I have a parenthesis, that refers to the order of the derivative. So let's look at a few example of degree and the order. Let's look at this one. You can pause your video And let's actually answer that, right? So anytime you can pause and do that, but I'll do it right now. If you want, you can pause. So here, the highest order is the second order, right? I only see second order and the first order. So the second derivative is the highest order. So the order is 2, and for the degree is 1, because the exponent of the second derivative is invisible 1 there, right? I know we don't write anything, but there's invisible 1. So the degree is 1. Remember, it's not 4. You don't look at 4 because 4 is the exponent of the first derivative. But first derivative is not the order. So you don't look at that. Let's move on to the next one. Let's look at this one. Again, you should pause and try that. So look at the highest derivative. So the highest derivative I see is third derivative. I see third derivative and the first derivative. So the order is 3 because that's the highest one. And the degree is 1 because of the same reason. The exponent here is invisible 1, right? The exponent here is invisible 1. By the way, the independent variable, that is x, that can be anything. We don't really care about that. We could have a sine x, e to the x to the power 1 billion. That does not matter. We're only interested in the unknown function y. Let's look at the next example. Here, the highest derivative is 5. So I see a fifth derivative and the third derivative, right? So of course the 5 is the highest derivative. So the order is 5. And again, the degree is 1. We do not look at the 2 because that is not the highest order derivative. So the highest order derivative is 5, and then the exponent here is 1. Move on. The next one. So I see a second derivative. Here, by the way, my function y is actually a y of t, right? Because I see the variable t, independent variable is t. And I also see a first derivative, and also this is a first derivative. So my order is 2, and I'm only interested on the highest order, and the degree is 1. Let's look at next one. Here, remember, whenever I have a parenthesis is the order of the derivative. So I see a fifth derivative, fourth derivative, third derivative, and the original function y. So here, of course, the order is going to be the highest derivative, which is 5. And the exponent of that fifth derivative is invisible 1, right? So the degree is 1. Let's do this one. Anytime you should pause and think. So let's look at this one. So I'm seeing a fourth derivative, fifth derivative, fourth derivative, and remember this is a power. That's not the derivative because I don't have any parentheses around 30. So that's actually a power. That's actually exponent, not derivative. So here the highest derivative is 5. That's the fifth derivative. And the exponent of that highest derivative is 2. So the degree is 2. I hope it helps. Thank you very much.